Our cities are facing a ton of challenges, but one of the biggest, one that hits close to home for all of us, is housing. It can feel like this impossibly tangled knot. But what if we had new tools, new technology, that could help us not just see the knot more clearly, but actually start to untie it? Okay, let's dive in and see how algorithms are starting to decode our urban future. I want to start with just a single number, 6.2. Right now, it doesn't mean a thing. But in the world of housing, this one number tells a story about a massive problem hiding in plain sight in our cities. So what is 6.2? Well, it shows this giant gap between what we think is affordable and what's actually happening. Generally, a house is considered affordable if it costs about 3 times your median annual income. But a huge study of 200 cities across the globe found the real median is 6.2. That is more than double. This isn't just a little bit of a stretch, it's a sign of a global affordability crisis. So here's our game plan. First, we're going to look at just how big this problem really is. Then, we'll get into a really cool way AI is predicting gentrification from space. After that, we'll jump over to Seoul to check out a smart housing deal, and then uncover a pretty surprising twist. And finally, we'll tie it all together to see what this means for the future of our cities. Okay, let's start by getting a real handle on how widespread this housing crisis is. I mean, the data paints a seriously stark picture. So here's the kicker. Using that standard 3 times income rule, a staggering 90% of the cities in that study were found to have unaffordable housing. Let that sink in, 90%. That number, 6.2, it's not some outlier, it's become the norm. This is basically a global stress test that most cities are, frankly, failing. All right, so when you're facing a problem this huge, you start looking for a new playbook, maybe even some high-tech tools. Let's head to New York City, where researchers are using satellites in a fascinating way to get ahead of neighborhood change before it even happens. So the old way of tracking something like gentrification was to use census data. The problem? It's slow. It's broad. By the time the data tells you a neighborhood has changed, well, it's already happened. This new method is a total game changer. It uses AI to scan satellite photos, giving planners a real-time, super precise view of physical changes, right down to a single building. And it all centers on this key idea they call building reconstruction intensity, or BRI. It's a simple but really powerful concept. When you see a whole bunch of demolition and new construction clustered together, that's often the very first sign that a wave of investment is coming in. It's an early warning flare that gentrification could be right around the corner. So how does it actually work? Well, the AI basically acts like a detective. It sifts through decades of satellite images, and it's trained to spot the unique light signatures of a construction site. You know, the color of bare earth after a demolition or the glare from a brand new roof. When it sees a sudden spike in this activity, it flags the area, creating a risk map that basically screams to city planners, hey, pay attention over here, something big is happening. And this isn't just some sci-fi concept, it's shockingly accurate. The models they built were able to spot these construction events with 87% accuracy. Just think about what that means. Instead of just reacting to displacement after people have already been pushed out, cities could have this incredible early warning system to get ahead of the problem. Predicting risk is one thing, right? But how do we actually get more affordable housing built? For that, we're going to shift gears and head over to Seoul, South Korea, where the city tried to strike a really clever deal with private developers. The policy was a classic land value capture deal. Here's the gist. The city went to developers and said, look, we'll let you build much bigger, taller, and more profitable buildings near subway stations. In exchange for that valuable permission, you have to set aside some of those new apartments as affordable housing. It's a really smart, market-based way to get housing built without spending public money. And if you just look at the numbers, man, it was a massive success. Between 2016 and 2023, this program created over 13,000 new affordable homes for young people, a group that was getting totally priced out of the city. On paper, this partnership was a home run. But this is where the story gets a twist. Because when you create that many homes, you have to ask a really important question. Where did they actually get built? And the answer to that question reveals a kind of hidden bug in the system. And this is where it gets really, really interesting. Because it turns out the very thing that made the policy successful also created a totally unintended and pretty unequal side effect. See, all that new affordable housing wasn't spread evenly around the city, not even close. It was all clustered together, creating what researchers call spatial inequality. To figure out why, they turned to another type of AI called explainable AI, or XAI, to basically peek under the hood of the housing market. And what the XAI model found was pretty stunning. The single biggest factor that predicted where these affordable homes would be built was a high land price. That was followed by other things you'd expect for a luxury development: big plots of land, lots of development potential, and great transit. In other words, developers were putting these affordable units in the exact same super valuable, super profitable locations they wanted to build in anyway. And right there, that's the paradox. The whole policy worked because it tapped into the profit motive of the market. But that very same logic meant developers naturally shied away from less profitable areas, even if those were the neighborhoods that desperately needed affordable options. Its greatest strength was also its biggest blind spot. So, what do we do with all of this? How do we take these incredibly powerful new tools and insights and actually use them to build not just smarter cities, but more importantly, fairer ones? But when you put all these different pieces together, a kind of strategy starts to take shape. First, we have to plan ahead and make sure land is available for growth before it's a full-blown crisis. Second, we need to use these predictive tools as an early warning system to protect communities. And third, we have to design our policies to be more flexible, with smarter incentives that guide development to where it's needed most, not just where it's most profitable. You know, in the end, the challenge here isn't really about the technology. The AI, the satellites, the data, they're just powerful mirrors. All they do is reflect back to us the logic and sometimes the flaws of the systems we build. The real work is using the incredible clarity they give us to design better, more thoughtful systems from the get-go. Which really leaves us with one final big question. These new urban algorithms are showing us the hidden code that runs our cities. So the question for all of us is, can we take that knowledge and write a new code? One that's programmed from the very beginning, not just for growth, but for fairness too.